So, guys, welcome back to yet another episode of DSA Python series. And today we will be talking about spiral metrics, or you can say how to, uh, print spiral metrics. Okay. So, in the last lecture, we actually studied how you can, rotate a matrix by 90 degree. So, the idea was simple. We just have to find out the transpose of a matrix. So we did that logically, and then we just have to reverse each of the rows so that we get the 90 degree rotation of the matrix. Okay. Now, if you talk about uh, this question, okay, this is we have been given an m cross n matrix, and we actually need to return all the elements of matrix in spiral order. So what do you have to do? I need to return a list. Okay, so how do I know that I have to return a list? Here it is. This is the hint. It's been given in the question that we have to return a list. Okay, that should contain integer values. All right, and what all given? We have a matrix, right? And we have a list in list. Okay, so this is a nested list, which you all know that if you want to create a matrix, you need to have a nested list, or you can say you need to create a double for loop or nested for loops to create a matrix. Okay, now, so guys, this is one of the, you can say, a tougher side medium question. Okay, and I would say, before looking at the solution, uh, before jumping onto the solution, you just try it yourself first. Okay, give this question at least 25 minutes before you start looking for some hints, and that hint should not lead you to the complete solution. That will be just a step which will lead you to think more on that question. Okay, so that should be your idea. Okay, now, you have this m cross n matrix, and let me explain the question little bit. So if you talk about this question, this is the my n cross n matrix, or you can say this is my m cross n matrix. I have to print the elements of this matrix in a spiral manner. Okay, so I need to print 0 0, then 0 1, 0 2, 0 3. Okay, then 1 3. Okay, 1 3, 2 3. Okay, then 2 2, then 2 1, then 2 0, then 1 0, then 1 1, and then 1 2. Okay, so this is how you, I just told you the indexes, okay, of all these elements of the matrix. This is how you have to print the matrix. Okay, so it should look like you are building something, spiral manner printing of the elements. All right, so that is what the idea is. Let us try, thinking for some solution. Okay, what do I have? Uh, I have some elements, and I can assume, uh, you know let's say, some variables such as top, left, bottom, and right, because I need to have those endpoints, right? When I have those endpoints, then it would be good for me to traverse through those variables. Okay, so that will be my idea and that will be my thinking. Okay. Okay, why I'm taking this top bottom. Okay, let me just first take the top left and bottom and right, all those things. Okay, then you will come to know what actually I'm doing, right? So so my left, and it will be left and top. Okay, so I'll just see, I'll just write left is equal to 0, right? So this is my left. Okay, and top also is equal to 0, right? If you talk about the column, then I'll take top also is equal to 0. I'm just assuming, you can take any variables, whatever you feel like. Okay, so I have just took these two variables, and what I'll do is, uh, let me, I'll just try to guess, or try to write a right and bottom. Okay, all right. I'll just say right is equal to and bottom. Okay, so my right will be this and my bottom will be this. Okay, so let's see from here. What is my right? So right will be, it will be the number of columns minus 1, right? Index. So all I am writing here is indexes. Okay, I'll just delete these. So my right will be column minus 1. Okay, so what is my number of columns? Number of columns is my m cross n matrix. Okay, where is it? Okay, this is my m cross n matrix. So n is my column, so right will be n minus 1. Okay, and bottom will be m minus 1. How bottom is m minus 1? This is my bottom. Just count the rows. Okay, and why I'm subtracting minus 1? Because this is actually the index which is starting from 0. So the last element will be, obviously, the total number of elements here, if you count it, it will be 3. Okay, so if bottom is m minus 1, then my counting of element will be 0, then 1, then 2. And what is 2? 2 is basically m minus 1, because here m is 3. So that is 3 minus 1. All right. That is why I am taking bottom as n minus 1. Similarly, right as n minus 1, because I am talking about indexes. Okay. And I'll put these variables into the indexes. Why I am doing this is because while I traverse through right, I have to keep one thing constant. Okay. So when I am traversing through right 1, 2, 3. Okay. Here, when I am traversing through 1, 2, 3, then I have to keep this row constant. So what is my row? That will be my uh, top. Yeah, that will be my top. And when I traverse through here, then, or traverse through here column, then I have to keep my left as constant and uh, right as constant, and minus one, right? Then only it will traverse downwards and upwards, right? Because the other axis is not constant, right? The other, I would say, the variable. So in that case, I'll traverse through j, or yeah, I'll traverse through I. While going up and down, I'll change my I. While going left and right, I'll change my j. Why I'm changing j? Because columns are changing, right? I'm changing the column while I'm traversing from left to right. While I'm traversing from top to bottom, my number of rows are changing. Okay, so my I will change. Okay, this is the idea. Okay, so let's do this. So yeah, now I'll just traverse it. Okay, so for I in range 0 to 0 to m. Okay, m is equal to len nums, sorry, matrix, and n is equal to len matrix of 0. Okay, so this will be my m and n, and I have assumed certain more variables left, top, right, bottom. Why? Because I have to keep something constant whenever I traverse at certain direction, right? That is why I have to keep certain elements as constant. I cannot do everything in iteration and try to keep that. It will be very tough for me. Okay. So for I in range 0 to m, then 1, 2, 3. I'll just see that this is 0 to m or j in range 0 to n. That is also okay. What I'm doing is I have to append. Yeah. Now I just have to append in result. So result I have already defined it. Let's see whether it result dot append matrix of. Now what I have to keep constant, I have to write as it is from this left, top, right, and bottom. So right now I have to keep this top row as constant. So row will be top, that is 0. Okay, and my column will be j. Yeah, it is going right. So it will start printing, like it will start appending into that result. And then what I'll do, then I'll say result, again result dot append matrix of. Now I have to keep my right, that is n minus 1. Now the right one will be column, no, so the number of columns is m, so right will be m minus 1. Okay, and bottom will be n minus 1. Okay, just for understanding. Okay, so I'll just say my I is changing, right? When I go down, my I is changing, so I'll just keep I, but that will be I plus 1. I, because if I keep I, so I is here 0, so it will again print 3. I have already printed 3, so I'll just say I plus 1. Yes, so that I left that 3 and I jumped to 6 to print that, right? And then so the main logic is this, that's it. Rest all is traversing, that you can do it very easily. So the main thing is this, if you remember this, if you know this method, okay, because there is one and only one method to solve this question, spiral matrix. Okay, if you just know this, I have to keep some variable as constant, That is all you want in this question. There is nothing left in this question, right? So matrix of I, and it will go up to what is my constant. So my bottom, sorry, my right is constant, so I'll just say right. Okay, where right is m minus 1. So it will, yeah. Now next will be result dot append matrix of. Now I have to travel this direction, but my 9 is already printed. Okay, so once my 9 is printed, I need to print 8 and 7. So uh, I have my bottom, I have my this, my bottom and minus 1 is constant, and I'll just traverse it in the left direction so that my j is changing. So j is right now, but I have to do reverse. So that will be j minus 1. So bottom, will be j minus 1, and it will be minus minus. So what I'm doing is I'm just appending one element and moving to this. I don't have to do that. Rather, I have to, write every time for these loops. What if I prepare a function where, so here and here also, because otherwise it will, so this will, run fully, then only it will go to this. Yeah. See, this is how you develop the logical thinking. Firstly, we just wrote simple sentences how to append. Then, when started to think in the dry run format, then we actually found out that this j is incrementing every time. But with this j, the next command is going in this direction, so there is some hodgepodge going on. So what I did, I realized that this should be independent. Once this is completed, then you go down. When this down is completed, so this is down, we are going down. When this down is completed, then we go to the left. Okay, but when we are going left, I have to put my j in decreasing order. Okay, so here I have to do something. Yeah. Okay, so I'll just search how to reverse this function. To reverse it. So I'll just have to use range n minus 1 minus 1 then minus 1. Okay, for j in range. Okay, So for j in range n minus 1, then minus 1, okay, then the step of minus 1, so it will decrease, and I'll just have to say this j. Okay, now again I'll start using this for loop, and it will be now m minus 1 wala. Okay, so this I'll copy, I'll just copy this, and for I in range m minus 1 minus 1 comma minus 1, and result dot append matrix of, now I have to move it from 7, 4 and 1, so my column is constant, so what is my left left column? Okay, so column will be on the y wala, so this is left, and what is my right will be I, that's it. So I have to traverse from m minus 1 to, but that should not go up to 1. I don't want that to go up to 1, I just want that to go up to 1. So instead of 1 I will just say top plus 1, top plus 1, whatever is my top plus 1. Then it will go again to the left, but that left will be top plus 2. I think now there is some problem. It will go to top plus 1, then it will turn this way. So next will be again this. But there has to be some changes in here. I'll just say append matrix. So from here I will just say top plus equals 1, and what about bottom? And bottom left plus equals 1. Let's try to return result. List index is out of range. Okay. Yeah. So it should be right plus one, no, because I have to include all up to this four, no. Okay. And that should be left bottom plus one. This is also correct. Any suggestions, guys? Yeah. Top plus one is inside for loop. Top, top, bottom, left, right, top, bottom, right, left, top, bottom. I think we just have to do some juggling here so that we get uh, left to right. I have to append matrix of G. Okay, I have done that. Okay. Okay, after this for loop ending, I have to do that. Okay, okay, okay. Still wrong answer, but I am getting something. 1, 2, 3, 6. 1, 2, 3, 4. 4 is gone. Okay. At least I got 1, 2, 3, and but why it is not printing all the values of j? Top is less than 1, left is less than or equal to right, and left is less than or equal to right. Okay, so it is right plus one more. That is y, but it will not go up to right plus 1. It won't go. Then what? See, for j in range left to right plus 1, okay, let us dry run it. So left is my this 0, right is my uh, m minus 1, right is my n minus 1. What is my n? N is my length of matrix of 0. Okay, so this is the number of columns. Okay, this is number of columns. Okay, so right is my n minus 1, right, and bottom is my m minus 1. Okay, so I have to have top is less than or equal to bottom and left is less than or equal to right. J in range from left to right plus 1. So j will start from here. Okay, just consider the column. It will start from here 1, 2, 3, and it will go up to 4. So matrix of top, my top is 0 as of now. My top is 0. With top, I have to traverse j from left to right plus 1. So what is left? Left is my 0. Okay, and top is also 0. So 0th, in 0th rows, I have to in 0th row I have to traverse this j. So that will be 1, 2, 3, 4. It will print up to 4. Why it is not printing? Why it is not printing? Okay, so in this range of left, it should be left minus 1, right? And it should be top minus 1. Then only it will include all the range. Okay, this was the two problem which, yes, now we are getting the answer. So what mistake we were doing? I was just considering top, up to top, but for this I range I have to consider top minus 1. Why? Because otherwise it will not consider the last element, right? It will not be considering the last element, and this is the step of minus 1. Okay, so now we are getting the result after so much of brainstorming. Okay, so guys, you can see here, I'll just explain it once again super fast. So what I have done is, this was not coming to my mind, but this should be in your preparation list, because this you have to consider, because it is making the task easier. If you juggle with I and j, then it will be a big problem for you. Okay, so just consider left, right, top, bottom. These are all the number of rows. Okay, terminating rows and columns. Okay, that's it. Why? Because you have to keep those rows at one iteration. You have to keep those rows constant or those columns constant in each iteration. Okay, so in each iteration you have to keep something as the constant value. All right, so just forget about this while loop. We will just start writing the code with for loop. Okay, so for loop will contain right plus 1, because it has to include this last element also, because for loop, the syntax is such that it excludes this, the last element, right? If we make it up to n minus 1. Okay, so right plus 1 I should keep, so that it considers the last element as well. I'll just append matrix top of j. So top is my 0th row. Okay, this I have already considered. So the top, I'll just say it is top row, and left will be my leftmost column, leftmost column. Okay, right will be my rightmost column, rightmost column, and my bottom will be my bottommost row. Now you will, it will be easy for you to understand. Okay, now whenever I put this j, so it will traverse up to 4. Now what I'll do, I have to go down. So while I go down, I cannot again include this 4, which is my top row. So what I'll do, I'll just say top plus 1. So I came on this 8th element directly. That is why I did top plus 1. Now again I started this for loop from top to bottom. Okay, from top to bottom. So this top I won't consider because it has already been considered in the horizontal iteration. Now while I do top iteration, I should not start with 0, I should start with 1. Okay, 1 means 1 index, first row. So I should not keep calculating this is first row or this is second row, third row. I will just do top plus 1. Okay, so it will come here. Now I'll iterate from top to bottom. So the top value will be 1. It will become 1 because it was initially 0. So it will become 1. So 1 to bottom plus 1. So bottom plus 1. So then it will consider this 12 also. So bottom plus 1. Now I'll append matrix of I and right. What is my right? Right is my rightmost column, because on this rightmost column only I have to traverse. So I have to make this I value iterate from top to bottom. So this I will be I, and this j will be right, that is constant. That is why we are taking this right, left, top, bottom, right. Now once this iteration is done, what I'll do, i'll I'll have to go this side. While I go to this side, I just don't take this 12 again. So what I'll do, I'll just do I'll just do right minus 1. This is my right column. I'll do right minus 1 so that I come to this 11th position. Okay, this 11th element, and again I'll do iteration. So in iteration I'll have this negative for loop, okay, going in the backward direction. But for 9 to get considered, I have to do left minus 1. Otherwise it will again, it will not take this 9 element. So my last iteration should be up to left minus 1. This is my left minus 1. Okay, and the step of minus 1. And what I'll do, bottom is my constant. I'll just do j because j is getting traverse. This is traversing, no? J is traversing. So I'll just put j, and this I will be my constant bottom. Okay. Now when I reach 9, then I have to push this up. So with this, I will just say bottom minus equals 1 every time. Every time it comes in this direction, it will always do bottom minus 1. Okay. Okay. After all these 4 iteration, okay, we have to check whether top uh, whether this left is less than or equal to right. Okay, if this left is less than or equal to right, okay, then I'll just say okay, if left is less than, I'll just say bottom to top minus 1. It will again traverse from bottom to top minus 1. Similar trend. Okay, similar trend. So left will be constant. Okay, but we have to put this condition: left should be less than or equal to right. Then only it will go up. Otherwise it can go up to end, and again this will start doing again rotating like this if you don't stop it. Okay, if we don't stop it, this is the stopping mechanism. This is stopping mechanism. Okay, mechanism. If we don't stop this, okay, it will go up to this one, then again 1 2 3 4. So it will print this infinite times. Okay, we don't want that. That is why we are putting this condition. If left is less than or equal to right, if left is going more than right, then it will stop, right? It will break the loop, and ultimately it will return the result. That's all, guys. We'll just submit it. uh, I'll just submit it. So guys, trust me, such kind of explanation is not present in YouTube, especially for this question. I'm assuring you, if you get such detailed analysis of this question, then you just comment on, you can just comment and tell me who is that person. Okay, otherwise there is no YouTube video where you will find such huge, such elaborative explanation on this matrix. Okay, people will directly put code and they will just, just execute it. Okay, so what we have built today is the, repeated testing, repeated analysis of what we are doing, what wrong we are doing. Okay, this will basically lead us to the thinking on how you can, traverse spiral matrix. Okay, once you do this juggling for 1.5 hours, you won't be requiring any other sort of such questions to do again. Okay, as a practice. Okay, just do 2 or 3 questions, try it on your own, keep failing, keep, you know uh, uh, keep improving. Okay, ultimately you will get the answer. Try to look 1 or 2 hints. There may be certain cases where you won't be, where sometimes there is a situation where you don't find a code, or you just don't know how to traverse in some other direction, like in this situation. Okay, so you just google it, how you can traverse backward. Okay, if you don't know how you can traverse backward, just google it, just take a hint, and then again start on this lead code, right? So that sort of exercise if you do, then it is very much possible that you will able to grasp each and every concept, and you won't be requiring any mentor to do it, or any YouTube video sort of. uh, so this is all, guys. I mean, you don't require a lot of YouTube videos. If you start looking on to those videos, then you won't be able to understand each and every nitty gritty of the question, right? So that's all for today. Let us submit it. So what is the time complexity? Simple. The time complexity is order of n square, because there are, this while loop is going on, and this for loop is also going on. Okay, just submit it. Okay, so this has been, all the 27 test cases have been passed, right? So this was one of the, I would say, very good question. Okay, very conceptual question. Okay, if you do this, then half of the arrays is complete. More than half of the arrays is complete, right? So that's how. So there are more challenges: spiral matrix 2, spiral matrix 3. Okay, these challenges you can do, and if you want me to, do these challenges in our daily assignment, then I would love to post certain videos on this, or we can arrange a live online DSA discussion on these matrix challenges, right? Okay, guys. So that's all for today. Keep listening to my videos and keep practicing till you succeed for cracking any sort of interviews in good product based companies, right? So bye bye and good night.